Good afternoon. Good afternoon, and thank you for joining us for the Melanoma Research Alliance 2021 Melanoma Exchange Patient and Advocates Forum. I'm Michael Kaplan, President and CEO of the Melanoma Research Alliance, and I'm thrilled that you've joined us today. For those of you who may be a little less familiar with MRA, we were founded in 2007 by Deborah and Leon Black with the help of the Milken Institute. Our mission is clear and simple, though hard to get to, and that's to end suffering and death due to melanoma for all by collaborating with all stakeholders. We're a small team with a big impact, just 10 employees, 4 of whom are scientists. We're guided by our scientific advisory panel and our board of directors, which includes 7 individuals who've been diagnosed with melanoma and several more individuals who've had a loved one impacted by melanoma. Together, along with the help of several volunteers, we've been able to award over $130 million to new research around the globe over the last 12 years. And I suspect, as many of us here today already know, that research has had a major impact on treatments available today, technology for detection, and most importantly, improved health outcomes for patients. If you're interested in learning more about the research MRA funds, please check out caremelanoma.org/grants to search the grants issued by country, institution, investigator, or key term. While our team is immensely proud of the research advanced, at MRA, we know that researchers alone can't solve the challenge of melanoma. That's the whole reason the word alliance is part of our name. We believe the war on melanoma can only be solved with all stakeholders engaged, and critical among those are patients and patient advocates. From your own self-care to engagement with clinical trials and raising awareness through your stories, that's how together we can win the war on melanoma. We have a great program lined up for you today, but before I get to that, I'd like to take a moment and thank our sponsors that make this all possible. A huge thanks goes out to the forum's presenting sponsors, Merck and Novartis, our gold sponsors, Natera, Oncosec, and Pharma, along with our silver sponsor, Alkermes. You can learn more about each of the sponsors by going to the Expo button on the menu on the left side of your screen. In addition, we're excited to have several other partners spotlighted in the Expo, including UPF clothing makers, Summer Skin, Cabana Life, and Sun 50, men's sunscreen maker, Get Mister, and sun care Spot My UV detection stickers, among many more in the exhibitor booth. Several of the booths include direct links to some of our partner store and even discount codes for purchases through them. As an added incentive to get all of you to show love to some of our partners, for each booth that you visit today, your name will be entered into a raffle to win one of 10 gift baskets for participants. So visit all 11 booths at the Expo, and you have 11 chances of winning one of the 10 gift baskets today. Now, on to today's program. We're really glad you joined us for part 1's program today, in which we're going to look at updates on the treatment landscape, followed by tips and advice in surviving and thriving with melanoma, and then the latest biomarkers and guiding treatment. And then last but not least today, breakout groups where each of us will have an opportunity to network with one another and learn a bit about each other by topic. But before we go to the program, we'd like to take a moment to get a sense of who is in the room with us today. So on your left side, you should see a polls, and there will be some polling questions that are put up in front of you. The first question today is, how has melanoma impacted your life? If you could go to that question, it's at the first question at the bottom of the poll, and select whether as a melanoma patient, a melanoma survivor, a loved one, a clinician, a researcher, or a sponsor. And I believe, Rachel, will you be showing us the results on this today? We'll give it a minute to see what comes in. All right. Before I go to the second question, I'm just going to share what I found in terms of attendees. We've got about 30% of those joining us right now are melanoma survivors. 30% are a loved one or caretaker. 27% clinician. And the data keeps changing, but we'll keep moving forward in the questions so that we can ensure we get to the program. The second question today, we just want to have a sense of what people know about melanoma. So the question is, today, can you tell us how many people are estimated to be diagnosed with invasive melanoma in 2021? Will it be 106,000 people, 100,000 people, 75,000 people, or 50,000? And as populate polls, I can tell you the first one has at least gotten an answer right. Yes, and so people are getting it. And in fact, sometimes you may hear different statistics from some of the melanoma groups across the US. You'll hear close to 200,000 new melanomas in a year. That's because they're talking about in situ. But when we talk about invasive melanomas that break further down through the skin, we expect 106 in the coming year. We're going to take one more question before I move on to introduce the moderator for the next section. And that's the third question here, which is, what percentage of cancer patients do you all assume participate in clinical trials? And the options are 100%, 50%, 25, or 5. This is going to be our last question before I introduce our moderator. And while people are thinking about it, I will share with you that it is far short of 100% without giving away the answer. And I will share with you our top goal is getting more people involved with clinical trials via our clinical trial navigator on the MRA website. I wish the person is 50% today. 5% of patients enroll to get clinical trial the only way to treat. I think answers questions are still coming in throughout today's still show up in the poll panel. Staying engaged, but more about as we move forward with the program. Communications and patient engagement. Cody?
So excited to be how exciting event year. And while together and there were hugs and great energy at the space, I know that we're going to replicate as much as humanly possible virtual format. Throughout the day, I'll serve as your host, and we'll keep things moving. We can get through our jam-packed agenda. And with that, I'd like to introduce our first session and speaker. This session is one that we do every year because it lays the foundation. Knowing where we've been and where we are is critical if we're going to really dig deep and understand where we are trying to go next. Dr. Lipson, who will be delivering the speech, is a cutaneous medical specialist at Johns Hopkins University. His research is early clinical trials with melanoma and skin cancers, and he is an MRA-funded investigator here. and bring back Dr. Lipson for the first talk.
Everyone, my name is and I am associate professor at the Johns Hopkins University School of Medicine and the Bloomberg Institute for Cancer Immunotherapy at the Sydney Cancer Center. I'm invited today to talk about the melanoma treatment landscape. Relationship. A couple of objectives. First, we'd like to discuss melanoma and research landscapes that include standard therapies for patients with advanced melanoma. I'd like to discuss some of the obstacles to providing benefit to all patients, including those with other types of melanoma. And I'd like to discuss some prominent bright spots on the near-term horizon space in melanoma. Let's begin with some standard therapies for patients with advanced melanoma. Typically, we think about standard therapies in three categories: immunotherapy, mutation-directed therapy, and chemotherapy. And today I'd like to concentrate on the first two, immunotherapy and mutation-directed therapy. And to begin our discussion today, let's begin by discussing immunotherapy. So I like to think of immune cells that swim around the body as sort of like a fire department. They're looking for things that shouldn't be there. They're looking for viruses. They're looking for infectious agents. They're looking for cancers that are growing that need to be attacked. And overall, immune cells are about things that are foreign. Them. And in fact, one of the reasons why the human system is so equipped to combat cancer is because it recognizes an infinite number of threats. Infections appear. The immune system has a capacity to recognize lots of different molecules in various shapes and sizes. The second reason the human immune system is so remarkable is that it can adapt as the threat evolves. And so as cancers develop genetic mutations that change the way the surface of the cells look, the immune system too can evolve right along with it and track those changes and adapt. Lastly, one aspect of the immune system that's valuable, it has memory, and it means it can provide protection after therapy. So, for example, when you get a vaccination, it's an infectious disease, oftentimes a single shot, you're now protected for many, many years. And this is often true with cancer immunotherapy. Once the immune system has been activated against a tumor, oftentimes the immune system continues to fight that tumor even after the immune therapy is long since gone. One of the most promising types of immune therapy is called immune checkpoint inhibitors. And if we go back to our fire department analogy for a moment, an immune checkpoint is sort of like hiding a fire hydrant from the fire department team. It makes it difficult for the fire department to put out fire if the fire hydrant is hidden. And immune checkpoint inhibitors are, if you will, that take down the barrier so that the firefighting can clearly see the fire hydrant, access water, and put fire. checkpoint therapies pull the brakes on the immune system. Their names listed at the bottom of the slide. Pembrolizumab, nivolumab, ipilimumab, you might have heard. And what I've listed here in this table are statistics of some clinical trials that have been published in the last years. Here are the percent of patients advanced melanoma who are alive at the 5-year mark after having been treated on some of these clinical trials. As an example, patients treated with pembrolizumab, 43% of those patients were alive at 5 years. Similar numbers with nivolumab, a very similar drug to pembrolizumab. 44% of patients were alive at 5 years. And if you combine two of these immune checkpoint inhibitors together, ipilimumab and nivolumab, that number is 52% of patients who are alive at the 5-year mark. So as you can see, this therapy is effective for some people, but certainly not everybody. And it's the job of clinical researchers to try to increase those numbers. Percent of patients alive at 5 years and beyond, as high as possible. So let's discuss some of the challenges that are associated with activating the human immune system in the ways that I just described. Using those drugs sometimes results in collateral damage, which means that the immune system can cause potentially serious injury to normal parts of the body. So, can we activate those immune cells that I was talking about in order to only the cancer and leave the normal organs alone? So this is sort of like an apartment showing somebody's house that's on fire. And in addition to putting out the fire, they also accidentally flood the neighbor's home. And so to keep the stream of water directed only at the house that's on fire, to keep the immune system directed only at the cancer, not with a new medication called relatlimab. Relatlimab is a drug that targets an immune molecule called LAG3. So anti-PD-1 in combination with an anti-LAG3 was one of the groups. The other group was assigned to receive nivolumab by itself, so anti-PD-1 as a monotherapy. And these results are just coming out, but what was recently released was that the combination therapy, the nivolumab plus the relatlimab together, controlled tumor growth for a significantly longer period of time than nivolumab. So we will learn more in the coming weeks as these data are presented. But this is an example of how combining two immune therapies can oftentimes be more powerful than using one alone. Another immune-based therapy that's on the horizon is called tumor-infiltrating lymphocyte therapy. A lymphocyte is a type of immune cell, and it so happens that many lymphocytes infiltrate tumors, meaning that if you took a tumor out of a patient, you would see among all of those cancer cells that they were immune cells hanging out inside the tumor, presumably waiting to be given the go signal to attack what's in front of it. Oftentimes, for whatever reason, lymphocytes are present in the tumor but unable to attack what's in front of it. And so the objective behind these therapies, these TIL therapies, is to take those immune cells hiding out in the tumors and activate them so that they are then able to attack the tumor. So that's basically how this therapy works. The first step is surgical removal of a tumor from a patient. And then within those tumor, the immune cells are found and extracted within the laboratory. And in the lab, they are activated. They're combined with some molecules that create activity in those immune cells such that they're now ready to go and attack tumor. In the coming weeks, in the weeks subsequent to the activation of the tumor cells, the immune cells in the laboratory, the patient then receives a few things. One is chemotherapy, and this is done to sort of wipe the immune system slate clean, so you have a clean slate to work on. Secondly, those activated immune cells I was talking about are then infused into the patient. And then after that, some additional drugs are given to sort of further boost the immune system. And this is a technology that's been experimented with for many, many years now, but is just now sort of coming into the mainstream, if you will. The medicine that is receiving the most attention is called lifileucel. And there's a trial that is it's been recently published of 66 patients, all of whom had advanced melanoma, all of whom had disease that had progressed after receiving standard immunotherapy and, in some cases, targeted medications, mutation-targeted medications, which I'll talk about in a moment. So all of these patients were previously treated and had disease that progressed through standard therapy. In the case of these 66 patients, we saw that approximately 80% of them experienced a reduction in tumor size. Sometimes that reduction was quite marked, and other times that reduction was quite small. What you're seeing on the bottom of the slide is called a waterfall plot, and each of those vertical colored lines represents a single patient. The line goes down. If the line is in a downward direction, it means that the tumor shrank. If the line goes up, that means that that patient's tumors grew. And you can see here that far more lines go down than up. In fact, 50 patients had tumors that shrank and only 12 patients had tumors that grew. So these results were presented last year, and we are awaiting some additional data. Another thing to understand about these therapies, about immunotherapies generally, is that we are experimenting with when we can use them. So one way that's happening is that we're trying to understand whether we can help prevent the recurrence of high-risk melanoma by using immunotherapy before surgery. So typically, when a patient with melanoma undergoes surgery, sometimes for a larger tumor, the risk that the will come back is quite high. What is being trialed at the moment is that in patients with melanoma tumors that can be removed surgically, we're administering immunotherapy up front, and we don't know yet which drugs are the best ones to give and for how long they should be administered. But shortly thereafter, those tumors are removed surgically. We don't yet understand whether we can safely decrease the size of the surgery that needs to be done. And then in the post-surgical period, we're trying to understand whether this approach will mean that melanoma tumors will come back less frequently than in patients who just undergo the surgery alone and did not get the immunotherapy. So that's on the horizon as well. All right, so now we'd like to switch gears and talk about mutation-directed therapy as another one of the standard treatments available for patients with advanced melanoma. Mutation-directed therapy. Well, every cell in the body has a job to do, and that cell is supposed to be following contained in that cell's DNA. DNA is a collection of molecules that need to be in a specific order to tell the cell exactly what to do. And a change in those directions, a single letter sometimes is all it takes to substantially change the direction of the cancer. So as you can see on the right, turn the word dancer. And that is essentially the signal that the cell is getting. A single mutation can oftentimes mean that a cell is now directed to grow out of control, and that is what forms a cancer. What are the mutation-directed therapies that are out there? Well, oftentimes the most common mutation that is searched for in a melanoma is called BRAF, and there are 3 combinations that are approved by the FDA. They're listed on the right. Dabrafenib and trametinib is one. Vemurafenib and cobimetinib is another. That more recently has been combined with an immune therapy called atezolizumab. And then encorafenib and binimetinib is the third. And so we typically use those medications standardly in patients whose melanoma harbors a mutation in BRAF. Another frequent mutant we see is NRAS. NRAS is a gene that we see is mutant in about 20% of melanomas. And in some patients, we use a medication called binimetinib, which is sometimes effective in stopping tumor growth. And then in other melanomas, another gene called c-KIT is mutant, and there we use a drug called imatinib for those patients oftentimes. So getting back to the likelihood of success in patients who have a BRAF mutation, for example, if you look at the percent of patients with advanced melanoma who are alive at 5 years after receiving mutation-directed therapy, one combination called dabrafenib and trametinib results in 34% of patients alive at 5 years. Another one, vemurafenib and cobimetinib, is a 39% of survival at 5 years. And then we're still waiting on the data at 5 years from the third combination, encorafenib and binimetinib. The trials were all a little bit different, but on balance, each combination appears to be approximately equivalent in terms of efficacy. So what are some of the challenges associated with mutation-directed therapy? Well, for starters, mutation is often just a temporary fix. By temporary, I mean approximately 9 months, sometimes shorter, sometimes longer. Having said that, in some patients, for reasons that are not yet entirely clear, the response lasts for several years. But that's generally the exception and not the rule. Another challenge is that in some cancers, we cannot identify a mutation that is responsible for the tumor growth, and so therefore we don't know what mutation we should be targeting. In other tumors, we can identify a mutation, but cannot target it. We don't have a medicine, a molecule, a drug that can get in there and that mutant molecule from cell to divide out of control. All this to say that a lot of scientific and clinical work is currently underway to address each of these issues. So now I'd like to talk a little bit about what is next. And broadly, what is next is widening the net. And by widening the net, I mean discovering effective therapies for patients that are not yet deriving benefit from the medicines that we have just talked about. So one of those patient populations are those people who were previously excluded from clinical trial participation. So for example, in the immune therapy space, with immunotherapy trials, oftentimes patients with autoimmune diseases, patients whose immune systems were not quite right to begin with, or patients who are organ transplant recipients, for example, kidney transplant recipients or liver transplant recipients, were excluded from clinical trials. This is an issue because those patients oftentimes need therapy, but don't understand how best to use medications because these patients are excluded from clinical trials. So we have a clinical trial that looks at one patient population, these kidney transplant recipients. Here is a CT scan from a 57-year-old kidney transplant recipient who had metastatic skin cancer. All those yellow arrows are pointing to tumors in this patient's lungs prior to giving her therapy. And as you can see on the right side of the slide, at 8 months, all of those tumors have gone away with the possible exception of that one little guy just on there. When the patient received immunotherapy, those tumors, as you can see, disappeared, but her transplanted kidney by her immune system turned her immune system on so vigorously it caused rejection of her transplanted kidney, and she had to go back on dialysis. The good news is that she had no evidence of cancer at about 4 years and has since received a new kidney, so is doing fine. But this is just an illustration of how difficult it is to treat patients like this who have immune differences. So this nationwide clinical trial that I'm leading is designed to find a safe and effective immunotherapy regimen against cancers that arise in kidney transplant recipients. What's next when we're talking about widening the net? Well, we need to discover effective therapies for patients who have rare types of melanoma. And perhaps the most dramatic example of this are patients who have uveal or ocular melanoma. So this is melanoma that starts in the back of the eye. Unfortunately, this particular tumor type often does not respond very well to immunotherapy. So the 5-year survival rates that we talked about at the beginning of the lecture don't come anywhere close. The 5-year survival rates in ocular melanoma are not nearly as good as what we talked about. There are mutations in ocular melanoma, but we have not yet been able to effectively target them. And so for that reason, we highly encourage patients to engage with clinical trials when possible. One of those clinical trials has recently shown some success. It is testing a medication called tebentafusp. And tebentafusp is a novel medication that helps immune cells direct their activity toward uveal melanoma cells. They kind of bring immune cells together with the melanoma cells and help the immune cell attack the melanoma. This has been submitted to the FDA, to the Food and Drug Administration, and the FDA granted what is called breakthrough therapy designation. So breakthrough therapy designation means that a drug that is a serious threatening condition has demonstrated preliminary clinical evidence and a substantial improvement over other available therapies. And so because this is such a difficult to treat disease, and because the benefits seen here using this medication, the FDA granted breakthrough therapy designation. There is a large clinical trial that is about to be reported in the next week or so that is comparing tebentafusp with standard therapy in patients with metastatic uveal melanoma. And so we should know more about this study and what the results are next week. So I thank you for your attention, and I'm glad to answer questions.
Hi, everybody. I want to, first off, apologize for all of the technical difficulties that we're having right now. We will make the full recording available to everyone, but we also know that not all of you were even able to listen to this, so we're going to approach question and answer with Dr. Lipson a little differently. So, Dr. Lipson, could you please, let's just start from square zero. When you're meeting a patient who's just been diagnosed with advanced melanoma, how do you start the conversation about the available treatment options?
Good to be everybody. I apologize for the technical. I just can hear me, right? Yeah. Very good. So it's a good question about how to approach the landscape for melanoma therapy in the setting of disease. Typically, I like to therapy in three categories. The or treatments that encourage the patient's immune system to see cancer. The second is mutation therapy, and that relies on knowing exactly what it is about the tumor that's making it grow, and specific medication based on knowledge that we can give to the patients to try to control tumor. So those are the back to patient-based therapy. And for instance, men with fruit disease participate in both women diseases as well designed clinical trial.
Thank you, Dr. Lipson. And how has that conversation shifted in the last 6 years?
Fundamental change. The therapies that have been developed, which have been supported by the Melanoma Research Alliance, have changed the landscape. Families of providers, types of patients, all of the medicines that I was talking about were just sitting with the past 5 to 10 years. So just in the way we treat patients with melanoma.
And you mentioned that you talked to patients about trials and the movement. How do you reduce the idea? It is something that for what you're going to get.
Sure. Maybe successful in what we already have.
Are there of when they come to an appointment with you? Might make the most out of this.
Patients through treatment and when you change in symptoms. We're giving about and cultural aspect when it shows that up.
And think about contact right now in 6 years.
It's a great
excited that I'm available to patients.
Yes, that. So one of the large just happened and our therapies that have shown promise in for three. That was just for the worldwide benefit several years. There was a number of in the last couple of days melanoma starts at the back of the eye, which is quite rare to treat. And again, it was seen there. So yes, that the potential
for patients. Is there anything else you want to share before we move on? And
some of the clinical trials are success. And I just want to appreciate the participants in the studies and to the MRA who are supporting the work we do.
great. And thank you. And like I said earlier, we will be making a full recording available to everyone if there aren't any technical difficulties, so that you can get that great presentation from it. Thank you again, Dr. And we really appreciate it. It's now my pleasure to introduce Dr. Sapna Patel by our next panel conversation. Dr. Patel is a medical oncologist and researcher at the University of Texas MD Anderson Cancer Center. Dr. Patel is an MRA funded investigator who specializes in uveal melanoma as well as melanoma and mucosal membranes. Dr. Patel.
Thank you. I'm just checking that you guys can hear me okay. Great, great. Well, welcome everybody to today's moderated panel session on melanoma and cancer survivorship. My name is Sapna Patel. I'm a medical oncologist, associate professor, director of the uveal melanoma program, and fellowship program director for the Department of Melanoma Medical Oncology at the University of Texas MD Anderson Cancer Center. Cancer survivorship is really multifactorial, multidimensional. It's personal for every patient and caretaker, and it really starts at the time of a cancer diagnosis. It involves living with, through, and beyond cancer. Let me say that one more time. Cancer survivorship involves living with, through, and beyond cancer. We often think of this survivorship in three phases. There is the acute phase, which really comprises the time from diagnosis until the end of treatment. And there's an extended phase that involves surveillance, and any aftercare for treatment side effects. And then we think of permanent survivorship, often when cancer is in the rearview mirror. Survivorship encompasses a number of emotions. I hope you're seeing the slide on the screen. You know, there's a lot of fear, anxiety, maybe there's some guilt, doubt, hesitation, insecurity, but ultimately, hopefully also some relief and pride with the cancer survivorship. There are a number of resources online, and I would encourage you to look at the ASCOcancer.net survivorship site, as well as the NCCN survivorship guidebooks. And for our rare melanoma patients, the audience members who are caretakers for rare melanomas, this diagnosis and survivorship often feels very isolating. But there are a couple of burgeoning resources for you to look at. The MRA has the RARE registry for our acral and mucosal melanoma patients. And the Melanoma Research Foundation has generated a patient registry for this uveal melanoma population. We ask that you participate in today's session by by putting your questions in the online web conference system. I know we've had some AV challenges, but we'll get through it today. I ask that you refrain from asking any personal medical questions, but we are happy to field your comments and concerns. We have a wonderful panel of experts and empaths joining us today. I'll give a very brief introduction, and then we'll ask each panelist to give us some more information on their background and perspective. Joining us is Dr. Bettina Yanez, an associate professor in the Department of Medical Social Sciences at the Northwestern University Feinberg School of Medicine. A clinical psychologist by training, Dr. Yanez's research is in the areas of patient-centered outcomes and psychosocial issues pertinent to cancer control and survivorship. Dr. Yanez is the recipient of a 2018 MRA American Cancer Society Pilot Award, investigating a web-based immune-related adverse events reporting platform. Dr. Lorenzo Cohen is the Richard E. Haynes Distinguished Professor of Clinical Cancer Prevention and the Director of the Integrative Medicine Program at the University of Texas MD Anderson Cancer Center. Dr. Cohen is also leading a 2018 MRA Teen Science Award, investigating the role of diet, mental health, and the microbiome in response to immunotherapy. And Mr. Keith Tolley is a father of 4 young children and 15 grandchildren. As a stage 4 melanoma patient, Keith has really gone through it all: surgeries, radiation. He's participated in a phase 1 clinical trial. He's been treated with both single agent and combination immune checkpoint blockade. And he serves as a consumer reviewer for the Department of Defense study sections. He also is actively engaged in patient care, patient advocacy, and mentorship. So Dr. Yanez, would you mind giving us a few minutes of your time delving into more of your background?
Yes, thank you. Can you hear me okay? Great. It's a pleasure to be here and to have been invited by the MRA to talk a little bit about my research and, of course, to field questions from patients and caregivers. So my research bridges behavioral medicine and health equity to really look at ways to improve patient-reported outcomes and clinical outcomes among individuals diagnosed with cancer so that we can translate really evidence-based research into cancer care. To address the concerns faced by many cancer patients, I've established an impactful and innovative research program focused on patient-centered care by engaging key stakeholders to address major public health problems facing cancer patients, optimize cancer-related outcomes, and enhance cancer care delivery. My research is organized into 3 distinct but overlapping components, including health equity and community engaged research, evidence-based behavioral oncology research, and implementation of patient engagement and patient-reported outcomes in cancer care. Specific to melanoma research, I do have a funded research project by the MRA in conjunction with the American Cancer Society to investigate how we can improve patient-provider communication regarding adverse events for patients who have initiated immune checkpoint therapies. And we do this, we've developed a platform that's online to help patients report any side effects or adverse events that they might be experiencing once they've initiated checkpoint inhibitors to their oncologists on a regular basis in case there's any concerns about any adverse events or side effects, with the goal being to facilitate communication related to adverse events and hoping that this will improve clinical outcomes down the road, but also improve the quality of life among patients who are taking checkpoint inhibitors. And I'll leave it at that. I know we have other panelists here.
No, that's great. Congratulations on your work, Dr. Yanez. Dr. Cohen, please go ahead.
Thank you. It's a pleasure to be here. I had a few slides to share, but now the slide share screen option has disappeared. Oh, there it is. Sorry. So I wanted to share a few slides because although, as you heard in the introduction, I am a faculty member at MD Anderson, I also have moved on to the other side of the exam table, so to speak. And just a quick story about how this all came about. I've been at MD Anderson now for almost 24 years, and back in 2018 had finished writing this book that you see pictured there called Anti-Cancer Living. I'm a behavioral scientist by training, particularly in the area of lifestyle and psychosocial interventions, things like yoga, meditation, and also acupuncture, diet, exercise, and what we call in this book the mix of six. And in March of 2018, when we signed off on the book, literally the last copy of the book, and that same day I had a biopsy of a lymph node that had been growing under my left axilla, and it actually came back as malignant. And at that point, there was no information on the exact result. Examination. Coincidentally, I received an email that same day from Michael Kaplan from the MRA saying that our MRA grant was funded to study lifestyle and melanoma. Lo and behold, a couple days later, the diagnosis came back that I had stage 3 melanoma. So this was, the irony was not lost on me. On the day I get an MRA grant, the day that I sign off on the final copy of this book on lifestyle and cancer prevention. But what we can get into, time permitting, and if there's the interest, is what we call the mix of six, the 6 lifestyle factors that we know are critically important for cancer prevention, first and foremost, but also to help control disease once one has it. You see there at the top, and most importantly, love and support, stress management, sleep and healthy sleep hygiene, appropriate exercise, diet, and decreasing environmental exposures. Of course, the environmental exposure that led to my diagnosis was probably the excessive number of sunburns under the age of 20, which of course we know increases your risk of melanoma. Most importantly, something that's not talked about in this area of lifestyle is ensuring that there is synergy between these components. An important thing to consider is when we're talking about something like stress management or diet or exercise, it's not just about feeling better. These 6 lifestyle factors influence one, if not many, of what we call these cancer hallmarks, the biological processes that need to be activated, so to speak, to allow that mutated cell in your body to grow and proliferate. And of course, we want to create an environment that is as inhospitable to cancer as possible by deactivating these processes. There's literally processes in the tumor microenvironment, of course, that conventional medicine and pharmacology are trying to have an impact on, such as increasing immune function, decreasing angiogenesis, decreasing some gene signaling pathways. And again, aspects of our lifestyle are going to influence these. And we can get into more details if there's questions around the microbiome, but the microbiome now, and in particular at the most recent scientific meeting, American Association of Cancer Research, that just happened earlier this week, overwhelming data showing that our microbiome, the bugs, the bacteria that live primarily in our gut, but also in the tumor microenvironment, are going to influence the efficacy of treatment. And data that's come from Dr. Wargo's laboratory, and more recently from the research we are doing with the MRA funding, looking at diet and exercise and other lifestyle factors, it's clear that a high fiber diet increases the beneficial effects of immunotherapy. I describe my own little experience around the microbiome and shifting of my own diet from diagnosis, and if there's questions, we can get into that in more detail. And just to close out, in terms of the mix of 6, it's critically important to harness your team to allow you to be successful in modifying your life and, again, making our body as inhospitable to cancer as possible. critically important. We can get into some of the details of this, that we need to manage our stress, because stress really does make the tumor microenvironment more hospitable to cancer growth. The sweet spot for sleep is between 7 to 9 hours. We need to exercise more on a regular basis, as well as just standing up and sitting less. We can get into what this means, the 90-10 rule, but you really want to be eating foods that we know are nourishing, that are healthy for us, and decrease the foods that are not. It's not deprivation per se, but just have them be a smaller portion of what's on your plate, and then decreasing environmental exposures, and of course protecting ourselves from the radiation from the sun. And at the end of the day, this is hard, but it's a practice. And the more that you practice, the better we will all get. And with that, I will hand it back.
Thank you, Dr. Cohen. I think the key is really, these are factors that are under our control. And when everything feels like it's swirling out of control with the cancer diagnosis, these are really important factors to consider. Mr. Talley, would you like to give us some more of your background?
Sure. Thanks so much for having me. Let me just make sure that can you hear me? Good? Yeah?
Sounds great.
Okay, great. I thought I would just unpack a little bit about my story and fill in some of the details that you highlighted. My story starts really with this small little pinkish spot that was on my left thigh that was misdiagnosed originally as some kind of psoriatic plaque. And I was told, don't worry about it. You should be okay. We'll just keep monitoring that. Well, about 3 years of monitoring later, what was interesting is I had a new care provider come in, and she took one look at it and said, we need to do a biopsy on that. And the biopsy results came back. It was melanoma, and which totally shocked my wife and I, because we had been told all along, at least we had been led to believe, that it was nothing to be worried about. And that really began my journey, my melanoma patient journey. And as you had mentioned earlier, Dr. Patel, over the next probably 2 years or so, my melanoma spread to quite a different parts of my body. I had to go from my thigh to my lymph nodes to my liver to my lungs to my bones and to different soft tissue areas of my body. And to combat the spread, I had to have, as was mentioned earlier, multiple surgeries. I participated in a clinical phase 1 clinical trial that featured a combination of a personal cancer vaccine and a PD-L1 inhibitor, and that was a great experience. I'm a huge proponent of clinical trials. I then had 3 infusions of ipilimumab and nivolumab, and these were incredibly helpful for me in terms of helping to stop the spread of the disease, but it came with a cost, and the cost was experiencing multiple and significant adverse side effects, which I think we might be talking about on our panel today. And then I had a series of radiation therapy treatments on disease spread in my shoulder, and then 27 infusions of nivolumab, which I just completed less than a year ago, July 2020. And since then, I've been doing my best to try to navigate the uncharted waters of being post-treatment. And it's an adjustment that's been a little different than I thought it would be. And I'm still getting quarterly scans and lab work at the site, the hospital that I've been experiencing treatment with. So I guess just to summarize, over the course of the 3 years, I kind of know what it's like to be misdiagnosed. I know what it's like to have to deal with rapid disease spread that seemed to be out of control. And I know what it's like to have had multiple surgeries, to participate in a clinical trial, to have radiation therapy, and to do both combination drug and single drug immunotherapy, and also to experience a number of side effects from those treatments, one of which is has caused me to be on steroids now, which will probably last for the rest of my life. And on top of that, the good news is I'm learning to live in a post-treatment world, which I'm praying will continue indefinitely. And I've had the privilege of being actively engaged in patient advocacy work and patient mentoring of patients at all different stages of melanoma. So that's kind of my story, and that's bring you up to date with what's going on. And yeah, I do have 15 grandchildren, 14 and one in the womb about ready to be born. So very exciting for us.
That's great. Congratulations. Actually, I think you're transitioning beautifully into our audience questions. You know, as a cancer survivor from the beginning, from the initial start of your diagnosis, I'd like you to maybe give us your perspective, and then I'd like to hear from Dr. Cohen on modifications for our stress. How do you deal with the anxiety that comes, maybe not so much waiting for a biopsy at this point, but every time you have to come in for scans and then wait to hear results? How do you manage that?
Yeah, initially I managed it pretty poorly because it was all pretty, a little frightening at the beginning. And what I had realized was much of my fear was coming from the fact it was really being driven by the unknown at the time of my fear. So I had really had no idea what was going on in my body, though I was reading about things and hearing things that might be happening. And, I didn't know if my body, the disease was spreading. I didn't know if the treatment was working or not working. I didn't know what was the next steps. So leading up to scans, which can be, even on this side of treatment, is still a little unnerving. I have found for myself, much of it comes from not having clarity about what the results will be or what is going on in my body. So what I realize is there's some things I can control, and I'm really looking forward to Dr. Cohen's sharing from his experience. There are some things I can control, and there's some things I can't control about leading up to scans, and then once the scans are taken and waiting for the results of the scans. And so trying to focus on the present, what I do know and what I can control, along with some of the things that Dr. Cohen lists in his, exercising on the way to scans, the days leading up to, I make sure that I'm active. I make sure that I'm connected to my support group. I make sure that I'm getting sleep as best as you can, waiting for scans and waiting for results, and watching and being very mindful of the what I'm eating, and things like that. So another piece to it, though, that wasn't on his list that I would just add and would love to hear others comment to, is the role of spirituality in the kind of the survivorship journey and process. And that's been very important to me, and it's been very helpful in managing stress. So I hope that helps.
Yeah, that's great. Dr. Cohen, I'd love to hear your take on modifiable or controllable anxiety factors leading up to scans and clinic visits.
Yeah, so this is a real issue, and colloquially we call this scanxiety, which of course is the anxiety in leading up to and then during the actual experience of getting scans, and then that waiting period. And my philosophy has always been, like Keith said, where he has evolved to is, this is something that we can't control. And if we looked at Eastern philosophies of being in the moment and the present is the key to avoiding a lot of anxiety in life about absolutely everything. That doesn't mean that we shouldn't plan. And one of the unique things about human beings over other animals is the ability to have metacognition and the ability to think about things that haven't happened yet. Now, that is in some sense adaptive because you plan, but planning for the worst and being worried about the worst, you're actually living that experience. And your physiological response to an actual diagnosis is not that different than the imagined worst case scenario. So when you take yourself there and thinking about, well, what if it has come back? What if, etc., all the what ifs that human beings live in, you are actually responding to that at a biological level. And that is not good for us. At the same time, you don't want to ignore the real fears and concerns. But I think the best philosophy is, if something negative comes out of a future scan, and my scans are coming up in June, I'll deal with it then. But until then, I'm not going to worry about it because there's nothing to do. Worrying doesn't help. So, the flip side of that is, if there's something to do, then do it. But if there's nothing that you can do, then, the worry is only going to be harmful. And as Keith said, double down on what we call the mix of six, up your healthy foods, your exercise, making sure that you're taking breaks from work, and for sure spirituality is super important, and for us it kind of could fall under multiple categories, but the support category, which is of course support from your spirituality and beliefs, as well as prayer being a very effective form of stress management.
Yeah. Could I just add one thing too that triggered from what Dr. Cohen was saying? I think what's been helpful for me too is to talk through my fears with someone else who's on my support team. Usually it's my wife or my kids. There's just something about being able to name the fear, talk about it, talk about your anxieties and your worries, and get input from others to kind of help level set and bring reality back into any vain imaginations that I've let run away to dark places. So I think there's wisdom and help for us as patients on the way to the scans and in between the scans and the findings, to just be honest and talk with our group, our support team, about what we're going through. And I have found that's been very helpful.
Yeah, I will say, as a provider on the provider end of this, we carry that anxiety with every patient. We're worried for you too, but we can't expend that worry before it's due. So very much aligned with what you're saying is you focus on the present, and then if you plan for a bad news, if you play the what if game, and patients ask this all the time, what if this, what if that? If you play that, it makes the hard news or the tragedy or the event that you have to endure no less tragic, no less difficult to endure down the road. And what you've done is spent the hours in the sands in the hourglass now on that emotion, when there are plenty of things to feel positive or grateful for. I think this transitions nicely over to Dr. Yanez. Maybe you can help us understand the role of supportive oncology and our support system in this cancer survivorship journey.
Yes, absolutely. I get this question a lot. What is supportive oncology? How do I get to supportive oncology? Who is part of supportive oncology? Most cancer centers have a program or department of supportive oncology. Each cancer center is going to define it a little bit differently, but usually it's a multidisciplinary team that's dedicated to listening and responding to patient concerns, promoting well-being, and treating each individual with respect and compassion. Some hospitals will encompass palliative care as part of their supportive oncology team, and palliative care can really help with symptom management, adverse events. Pain is a big area that palliative care specializes in. Sometimes patients have asked me in the past, well, isn't that only for patients, with metastatic disease? Am I a good candidate for palliative care? And I remind them that I think most patients can probably benefit from palliative care at some point, especially if they're feeling uncomfortable, if they're feeling side effects or adverse events. You can ask your main oncologist for a referral to palliative care, because really their goal is promoting health-related quality of life and symptom management, which a lot of patients at some point who've gone through treatment will experience some degree of symptoms or side effects. Also, part of supportive care, at least here at Northwestern, within our supportive care program, we also have a team of psychologists, licensed clinical psychologists who focus on, whose really whole training is in supportive oncology and the behavioral aspects of working with patients with cancer. We have licensed clinical social workers. We have a psychiatrist on board too, who really has a good sense of understanding of different types of interactions with chemotherapies and different medications as well. So it takes the whole approach to promote well-being. And I think for patients, we were talking about anxiety, and we started talking about, anxiety and fear in the context of scanning, the scanxiety, I think, as Dr. Cohen referenced. And that's a time when we see a lot of anxiety with patients as they're waiting for imaging results or biopsies. But when we see, and that's typical, but when we see elevated levels of anxiety that kind of persist beyond just that, waiting for results, and kind of are a part of the patient's life, where it's interrupting daily activities, their ability to socialize, their ability to sleep, appetite. It's really becoming something that they can't let go of, and it's a pervasive thought. There's different strategies that we can try to manage that anxiety. We do tend to see elevated levels of anxiety and distress among individuals who are going through treatment, and even cancer survivors. And working with a social worker or psychiatrist or psychologist through evidence-based programs like cognitive behavioral therapy can be very helpful for patients in treatment, and even post-treatment and during the survivorship phase.
Thank you. I'd like to ask an audience question, and maybe we can pass this around to everybody. I'll start with Dr. Yanez, and then Mr. Tolley, I'd like to hear your perspective, and then Dr. Cohen. When a survivor is experiencing side effects, either acutely related to treatment or in the post-treatment phase, what is the utility of, say, an online reporting platform, or directly communicating that, keeping a log, or just holding that until your next clinic appointment? And I'd like to hear from Mr. Tolley, maybe what happened when you were experiencing some of these? Were you feeling sort of stoic, as if maybe I shouldn't report these, I shouldn't tell the team every little thing that I'm registering? And then, of course, Dr. Cohen, what is it we can do from a maybe mix of 6 standpoint to combat some of our treatment-related side effects? So maybe, Dr. Yanez, you can talk to us about reporting these and the benefit of perhaps reporting in a timely fashion.
Yeah, absolutely. I think it's important to educate patients, start off with educating our patients, especially who are starting targeted therapies or checkpoint inhibitors, that maybe the side effects and adverse events that patients who are taking these types of treatments are not always the same as patients who are going through chemotherapy. So sometimes patients will say, well, I had a sibling, my significant other went through chemo for breast cancer. I understand that they had nausea and vomiting and hair loss. I'm expecting that. But when it comes to immunotherapy, the side effects and adverse events can be quite different. And what I always, we always tell our patients here, and one of the reasons we developed an online reporting platform was because we were concerned that maybe patients weren't reporting some of their side effects as quickly as possible. We had heard stories that patients were waiting until their next appointment a few weeks down the road to disclose a rash. that, was bothering them and getting worse. And when it comes to immunotherapy, you want to report the side effects as soon as possible. So we developed an online reporting system that administers a checklist of adverse events and side effects to patients on a regular basis in between their medical oncology visits. And when patients report an adverse event that's kind of, let's say, severe to very severe, we alert their clinician within a few hours about this side effect so that their clinician can become aware and reach out to them. We also let patients know, what are the most important adverse events and side effects, when you should be, contacting your oncologist right away. So I think it's important to keep in mind that if you catch an adverse event or side effect sooner rather than later, it can help with the management of that before it escalates. It can not only improve the quality of life of the patient, but it can also lead to better management approaches too.
And certainly in the breast cancer world, this early reporting actually improves outcomes. So I think we want to latch onto this in the melanoma survivorship world as well. Mr. Tully, was there any hesitation from you reporting side effects? Would you have used an online platform such as the one Dr. Yanis is describing?
Yeah. So in answer to your question, yes and yes. And I just want to say that, early on, when you found out that your disease has spread or they're talking about treatment, as a patient, the thought is not, wow, there might be side effects. It's how fast can I get this treatment in my body and will it work, right? And so there is great discussion from the oncologist and the oncology team about side effects. And I had a whole separate group that I went to talk to about side effects. But to be honest with you, I didn't really understand the magnitude of the potential until it started happening to me. Because again, my disease is spreading. There's a treatment for it that might work. Let's do it. And if I have a rash, I'm good. Let's go. And if I throw up, hey, I'm good. Let's go. Fast forward, then treatment starts, and your body just, in my case, I had over 30 different types of adverse side effects from the multiple different kinds of treatments. Your body starts feeling differently, and you're not sure, is it the treatment? Is it the disease? What's going on? And the great advice I got from my oncologist was she wanted to know absolutely everything new or different that was happening to me, and she wanted to know about it immediately. So, and she didn't just tell me, she told my wife and my kids the same thing, because she knew that if she just told me, I might not take it as serious, or I might want to kind of tough it through. And so I am a huge fan of any kind of journaling or online tool that goes right into the medical community, your care provider. I didn't have that. I had direct access via text and emails. It is life-saving.
And let me ask you, if I may, reporting anything new and different, how do you do that on Christmas Eve or on a weekend? Were you hesitating that you were kind of quote unquote bothering somebody?
Sure. Yeah, initially. But again, this comes back to your support team. My wife knew that something new and different was happening. My kids would find out about it. And very quickly, the questions would come from all of them. Did you talk to your doctor such and such? Did you let the team know? And we did have things happen on holidays. We did have things happen to me on weekends. And I'll tell you, I got to the point where I no longer felt I was imposing. I no longer felt guilty that maybe they had to answer a phone on a weekend or holiday, because of their insistence, my care provider's insistence, that they wanted to know. There's no waste of time in letting you know.
That's right. Early reporting, these direct to chart messaging systems, these online platforms, incredibly important. There is no bothering your oncologist on a holiday or weekend. That's not even a thing that goes through our mind. We love and support you, and we want to know as soon as possible. So, and we also do self-care. So we're not on call 365 days a year. We have a partner that will field the call, and then they can manage and help discuss it. But with these side effects, Dr. Cohen, I wonder what you think. Is there a mentality that patients should just suck it up and get through the side effects, or is there actually something that they can do to help control or ameliorate the side effects?
Well, there may be that attitude that this is expected, and so just grin and bear it kind of thing. But there are so many things that can be done to help manage side effects. Now, some of them are unavoidable. One that I had very early on was the endocrine-related side effects to immunotherapy, and I don't think there's anything you can do. And the only consolation for people out there with melanoma and getting immunotherapy, as you may know, that adverse events, depending on the severity, are actually a positive prognostic indicator. So that means your body is mounting the immune response. And there's evidence to show that adverse events certainly don't interfere with the benefits of treatment and may predict better outcomes. That's not to say you don't have great outcomes with no adverse events either. But there's this fine balance between creating the right amount of immune response and not too much. And if it's too much in an immune response, that's what is happening with these immune checkpoint inhibitor adverse events. Now, you heard from Dr. Vanez about cognitive behavioral therapy and some of these other strategies. There's also, of course, one of the go-to gold standards for cancer-related fatigue, whether it's immunotherapy or otherwise, is exercise. And though it may sound somewhat counterintuitive, I hadn't actually, of course, experienced cancer-related fatigue until after about my third course of Ipi-Nivo combo. And I got home one day and was just walking up the driveway, and the best metaphor is it felt like my feet were in cement blocks, and I could barely put one foot in front of the other. And I was processing this and said, wow, this is cancer-related fatigue. I had no idea how debilitating this was. And, the light bulb went off, and I said, I know the evidence of what I'm supposed to do, and all I want to do is flop on the couch. But, I got our dog in the leash and, started, plodding my way as best I could around the block. And halfway around the block, the fatigue kind of started melting away. Now, would it have otherwise if I had just flopped on the couch? Maybe. But the evidence is overwhelming that exercise is a good way to combat cancer-related fatigue. Some of the skin reactions that are really common, it's hard to know whether there's something behavioral. For sure, some of the inflammatory-related issues that happen in the gut due to an excessive immune response, which unfortunately leads to ulcerative colitis in a lot of people on immune checkpoint inhibitors. We believe the diet will play a role and the microbiome, but the evidence is still pending. But people who have a more diverse microbiome, and the best way to achieve this is through eating soluble fiber-based foods, which is essentially a primarily whole food plant-based diet, will have less adverse events. And this is turning out to be true for conventional chemotherapies as well as immunotherapies. And just lastly, a note about mucositis. So again, one of these shockers that I experienced when I got on the other side of the exam table was just this horrendous mucositis that just blasted out of nowhere. And from Ayurvedic medicine in particular, it's quite well known that cloves are a numbing substance. So cloves, literally the seed/spice that is used in many warm beverages and Indian-based cooking. So making a tea that is very strong with cloves, and not necessarily swallowing the tea, although you can, is something that can be quite useful. Of course, it's not going to treat, but it's going to help decrease the amount of pain. And at least, drinking what one could call an anti-inflammatory tea, cloves, cardamom, cinnamon, some of these other spices that we know decrease inflammation. Drinking something like that and exposing the mucous membranes to that, in the time before trying to eat, because of course severe mucositis means eating is excruciatingly painful, can be helpful to take the edge off. But circling back to the start of this conversation, it is critical. And of course, being at MD Anderson and a faculty member, it never would even cross my mind to not share an adverse event, regardless of the time of day, the day of the month, or from my perspective, whether I think it is not that big a deal. We need to rely on the medical experts to say, is this something that, one, we can do something about, or would it be something that just needs to be known? So it's critical to have that open communication, again, because there's so much that we can do. And I didn't even get into all the integrative medicine things like acupuncture and massage and yoga, meditation. The list is very long, so please avail yourselves of all these types of services.
Yeah, I'll say from a provider's perspective, we also have to do better about asking some of these side effects. There's a very colloquial thing that can happen between a patient and their provider where the question is asked, how are you? How are you feeling? And the very polite human nature response is to say, I feel okay, I'm fine, But that's not really a deductive question when trying to get to the bottom of somebody's oncology side effects. And I think, you both explained it very well. I think the questions are better phrased. Do you have the same amount of energy today that you had before your cancer diagnosis? Can you do the same things that you enjoy doing now that you did before? Are you eating the same? Is your appetite the same? I think we often ask questions that are not specific enough, and then we get some not specific answers back. It is crucial, really, to report as specifically, as early as possible. And as Dr. Cohen mentioned, let's not write off some of these integrative or alternative approaches that your provider team may be able to connect you with. I'd like to ask a question to Dr. Cohen really about this idea of diet. If you're a cancer survivor, you've been newly diagnosed, perhaps you're on treatment, or perhaps this diagnosis really is in your rearview mirror. There's a lot of talk about diets. Is ketogenic diet the best? Is a paleo diet the best? Should we cut out all sugar? Some melanoma websites talk about the Gerson diet. What is your take on diet and cancer survivorship?
Well, it's probably the most confusing area. And just before this meeting, I attended Society for Integrative Oncology webinar on fasting diets and fasting mimicking diets, which sounds a bit crazy too. I think you can boil it down to Michael Pollan actually said it very well, which is to eat whole food. Not too much, and mostly plants. That doesn't mean you need to be vegan or even necessarily vegetarian, but again, the data is overwhelming about the microbiome, and that is about having fiber in your diet. And again, healthy fibers are coming from plant-based foods. So can you eat red meat? Well, red meat in colon cancer, the data is pretty clear, not a good story. Red meat and melanoma, well, there's not a lot of evidence for that direct link. But there are healthier sources of animal protein, as well as healthy sources of protein that come from the plant world, nuts, beans, legumes, etc. So, a key is going to be variety. A key is going to be whole food. That means minimally processed food. So there's a paper that came out just 2 weeks ago showing that actually even highly processed, or what are called ultra processed healthy foods actually are not so healthy for you. And so, eating foods in some sense in their original form is going to be most important. And then lastly, and it comes back to the concept of processed foods, trying to maintain a balanced or level glycemic load. And what that means is that you don't want to have these big spikes in glucose. And of course, that happens primarily from if you consume a lot of products that have added sugars or that are highly refined, because the body is processing and extracting the glucose very rapidly. And then that leads to increases in insulin and insulin-related growth factor, all inflammatory factors. And this, is what one term for this type of diet is the Mediterranean diet. And the evidence is pretty overwhelming, but it's not just Mediterranean. The Asiatic diet, the South American diet, these diets that are what we could see as more indigenous, let's say ancient diets before we in food science created all these complexities of what diet should really look like.
So I think, for the audience, the key is it's really that Michael Pollan quote, right? Eat real food and not a lot of it. And, the takeaway that we're learning, at least in the melanoma sphere, is high fiber promotes a diverse intestinal microbiome to break down these prebiotic sources of food into short chain fatty acids, which are then interplayed with your potential immunotherapy or your mucosal immunity. So what does that mean? That means probably paleo diets, ketogenic Atkins, that are reducing your fiber content, reducing your carbohydrate content, may be counterintuitive to a melanoma survivor. And what does high fiber look like? We're often thinking of 40, 45 grams or more of fiber per day, and you're looking for really those complex carbohydrates. So I challenge the audience members to really, look at their foods and try to calculate how many grams of fiber they're getting per day. It's difficult the way we eat in the Western world to do that, but quite possible. I'd like to hear from Mr. Tolley if he changed his diet at all during his cancer journey, if you could briefly weigh in. And then a question for Dr. Yanez: what happens when people are interested in these maneuvers and they don't have access to it, right? They're at a small community facility. How do they tap into perhaps supportive oncology, integrative oncology, or some of these resources? Let's start with Mr. Tolley and see what he did with his diet during his journey.
Yeah, so when I was the sickest, I was least likely to eat, right? I mean, you just don't feel like eating. And during one of the infusions I had, we connected with a nutritionist, who specializes with working with oncology patients. And she shared a lot of what Dr. Cohen had just articulated. And so, one of the things in addition to that she talked about was protein intake. And that began for me really an awareness of the importance of protein. I already had an awareness of the importance of fiber, but the importance of protein. So I upped the level of protein, plant-based proteins, through smoothies and things like that, along with upping the level of fiber, and found that it was very helpful, very helpful.
That's great. I know we're running a little short on time, so Dr. Yanez, why don't you tell us about access to these specialty oncology services?
Yeah, thank you, Dr. Patel. I think that's a great question. Cancer centers vary in the resources that they have and the programs that they have. For patients who don't have maybe an in-house supportive oncology program, they can try accessing local resources that are within their city or town, but maybe outside of their cancer center, such as Gilda's Club or Immerman Angels. They are national organizations that will provide support groups for patients. Some of them do like art therapy, music therapy, different types of support groups for different, some of them will be like breast cancer support groups, prostate cancer. So you can see if there's also a support group for melanoma or just general type of support group for cancer patients. They also run support groups for caregivers. That's a good way to connect with other patients. I like the organization Immerman Angels. You can go online and they will actually match you with another cancer mentor anywhere in the country. So that's kind of a way to talk to somebody else and get a little bit more information if your particular cancer center doesn't offer that. Most cities and towns will also have psychologists who do specialize in oncology. So a lot of our psychologists and psychiatrists within our cancer center also have private practices outside of our cancer center. So they see patients elsewhere. So you might want to ask your oncologist or a nurse practitioner in your oncologist's office if they have a list of referrals for psychologists or psychiatrists that have worked with their patients in the past. So there could be ways to get access to these resources outside your cancer center. Just I was asking around or maybe others type of support groups outside the cancer center.
Yeah, that's great. And perhaps just in closing, in preparation for Dr. Leachman, who's coming up to talk about certainly primary protection, I'm wondering, Dr. Cohen, if you have any thoughts about environmental exposure, sunscreen use. Does a melanoma patient need to worry about getting a second melanoma? Can they throw the sunscreen away? What are your thoughts about kind of secondary prevention of primary malignancy?
Yeah, well, I'm not sure how strong the data is on a second primary melanoma due to something, for example, that we do when we're 50, 60, or 70. I think, with a lot of these cancers, and melanoma being one of them, kidney cancer, even breast cancer, a lot of the original mutations happened many years earlier. There's some suggestion with kidney cancer that first mutation that ultimately led to the clinical diagnosis could have happened 50 years before the clinical presentation. And so I think the same is true for melanoma. That doesn't mean, though, that we should not be protecting our skin. And my wife and co-author of the book Anti-Cancer Living, puts it in this frame, which is that, to the degree that you can take any pressure off of your body in managing any negative exogenous types of toxins, whether, so our body is well equipped to take care of a lot of these toxins and exposures, but it takes work. It'll take work on your liver. It'll take work on your kidney. It's going to take work, if you're getting excess radiation, sun exposure on your skin. A lot of the processes to fix that burn are going to that area of your body. And so, we want to keep all parts of our body as inhospitable to cancer as possible. So that means being as healthy as possible inside, outside, and decreasing exposures as much as possible.
That's great. I'm so grateful to all of our panelists in this lively discussion that we had today. I'd just like to summarize a couple of things that we really touched on today. Reporting side effects when you're a cancer survivor on treatment and even after treatment. There can be long-lasting effects, and you may think it has nothing to do with your treatment for several years. We certainly want to hear about it. So using these newer reporting tools to get that information to your provider is important. Naming your emotions, naming and sharing is a very powerful tool to overcome amygdala, stress. And I think we're just thriving as a society, and that's sleeping. We didn't get to talk about sleep hygiene and meditation and what that really looks like. Spiritual support, my feet is part of my life. So, I think all of these are your survivorship, your caretaker survivorship, and perhaps even your provider. Thank you to the Melanoma Research Alliance and to our panelists in the audience.
To science.
Hello. I want to thank RA so much. Thanks for the introduction. Thanks for the opportunity to create this presentation, because I was challenged by MA to help explain some of the technologies that are being used in diagnosing melanoma. Of course, everyone melanoma wants to know how firm is the diagnosis. And to understand, I think it takes a little more understanding of basic, and I hope that what we've done is to create a presentation that will set everybody up and understand what the strengths and the weaknesses and the limitations of our current state-of-the-art diagnostics are. So how is melanoma diagnosed? And I think it's really important. What we're going to talk about is a drill down into the ways that that melanoma is the ways that they are diagnosed. Let me. Okay, so what we have is what you can see with the naked eye. That's one way of diagnosing. But you can use a dermatoscope, so you can see more with the dermatoscope. You can see more in vivo focal microscopy, which I'll talk a bit more about. Don't worry that you don't know what that is yet. You can see more with a traditional microscope, looking at the biopsy. And you can tell more from molecular changes that have happened in the tumor. So what we're going to do is drill down into all of those areas of information. So starting at the body level, melanomas occur on the skin, but also occur in the eye, and they can occur in the mucosa, including the nose, the mouth, and the genital area. So you can have melanoma in a variety of places. If you start to look a little bit deeper down into the skin, you've got two panels here. One is the skin and mucosa, and the other is the eye. And each of those are independent organs. And so that if you look carefully, I want everybody to understand the structure, because we're going to start looking at real slides here in just a minute so you can see everything. And you need to know what you're looking at. So if you're looking at the top of the skin here, and here are the little hairs coming out, you got the epidermis, this purple wavy sort of the skin. It's comprised of a lot of skin cells, and then those are mainly keratinocytes, and the melanocytes live right at this junction. And underneath that is the dermis, and underneath that is the, and you can see sweat glands, and you can see glands from the fat that release oil glands into the skin. And here, right here, is melanoma. And it started as just a few melanocytes right here at the border between the dermis. It started to grow, and it began to grow uncontrollably. And it moved into epidermis, and then it started to extend down and it invade into the dermis. And that is the way the melanoma progresses in the skin and the mucosa. In the eye, there's separate different cells, and primarily in the iris, and those can make a melanoma. That's the colored part of the eye. Also have a melanoma in your body, and that's this melanoma there. And one of the more common places is the choroid. That's called also choroidal melanoma, and it's back here a little bit further in the eye. That's called the choroid. So now you've got a kind of idea of where the melanoma can start. What does it look like? So I'm going to start with a schematic, and we're going to start to think, and bear with me on this, because we're going to take this slow and steady, but we're going to get you to the point where you can really interpret the pictures that I'm showing you of real life situations. So here's a schematic, and this shows one of those melanocytes. Now remember, this is the epidermis. This whole area right here are the epidermal cells. They're the keratinocytes. And the melanocytes live right here at the boundary between the basal layer of the epidermis, and down below here, it's not pictured, but that's the dermis, which is this purple structure that you saw before. And what happens is the melanocyte reaches out, and it has these little pigment packets, these little brown pigment packets, and it distributes them to the keratinocytes, right? And here's what you see when you actually look under the microscope. Here's again a picture of the epidermis, and here's the dermis. And if you look right here, that's a little melanocyte that you can see right there. There's another one right there. So now we've shown what those things look like. How do you start to use that to diagnose a melanoma? And the way that we do that is we combine some molecular technology with cellular, these great histological slides called histology. So how do we do that? Well, the first thing, you start to, this is called an hematoxylin and eosin stained skin. This is the stain that when you have a biopsy that is taken from your skin, it goes into formalin, it gets fixed, and it gets stained. The first stain they'll do is hematoxylin and eosin. And what you can see is you can see those little melanocytes right there and there and there, but they're pretty hard to see. Here's just a close-up to kind of give you an idea of what's happening with these stains. So this is a beautiful picture. This is a picture where the blue and the cytoplasm is stained green here. And these are the way that melanocytes look when they're in culture. These are the little projections that are attaching to the keratinocytes when they go. And what we have identified is a marker called S100. It's a protein that's created on the surface of the melanocyte. And we've created antibodies that bind protein. And when you put antibody stain on top of the histology slide, what happens is it stains them darker brown. It will allow you to see melanocytes even better. But S100 isn't the only marker. Oops. There are other markers that are called MART1 is another one. And MART1 is an antibody called LNA. And this is what you see. You can see that these are even easier to see. So one of the ways that you can help improve the diagnosis of melanoma is to use some special stains that will allow you to see what the melanocytes look like, the pattern, the amount of stain that they have on them, which stains are positive and which stains are negative. And that's going to be the first thing that people will use to determine if you have a melanoma, is those special stains. But nowadays, this is where I'm going to get into the meat, and hang in here with me. I'm going to try to take you through one step at a time of the molecular level information that you need to know to understand the latest diagnostics. So let's pretend this is a melanocyte. And in the melanocyte, there's a nucleus, and the rest of it we'll just call cytoplasm. Now, this is really complicated stuff, but we're going to keep it really simple, that you have a nucleus and a cytoplasm. And in the nucleus, that's where the DNA resides. That's where you have all of the genetic material that is made up of DNA. Now, DNA, it's kind of like the code book. So if you were to think about the original Bible that was created, people wanted to transcribe so that different people could get it, DNA is like the original book, and RNA is like the transcription of that book. It's the message of each protein transcribed into RNA. Now, if you want to translate the book, that's like taking the RNA into protein, right? And the proteins are where the action is, right? The proteins are what are responsible for helping the cell repair itself as well anymore. It can't commit suicide if it needs to. And it doesn't communicate properly with the other cells. It starts to tell the cells to build more blood vessels to help with the defect in metabolism. It starts to tell them to grow out of control with it, for example. So the point is here that there are definite molecules that are really, really important in controlling cancer. And this is what has come to be known as the stepwise progression to malignancy. So it's a stepwise process. Any of these hits by themselves are not going to lead to cancer, because the cell is very resilient and it can counteract it. It can have alternate ways of regulating things for a long time. But as you get more and more and more hits, you stepwise move towards a progression to malignancy that ultimately, when you've got enough of the right combination, you end up becoming a cancer. The cell ends up becoming a cancer. And this is what, this is basically a really fundamental, important thing to understand, is that every melanoma is a unique cancer. It's genetically unique. No two melanomas have exactly the same collection of mutations that have led it to become cancerous. Now, there are some mutations that are more common than others, but none of them are identical. So how do we know? So that's the background. All of that was background to get you to the point of how do we know something's a melanoma? And the real answer is you won't know until it spreads past the skin to other areas and leads to life-threatening complications. That's the true definition of knowing when something is melanoma. But as we all know, that's a little bit too late. Wouldn't it be nice to know a little bit earlier than that? And so that's where biopsies, special stains, and molecular tests come into play. They are all ways to better predict if a mole is actually a life-threatening melanoma. And none of these are perfect, as you'll see. So what is the general principle of diagnosis? I think before we start to talk about how you make a diagnosis, it's important to understand that melanoma exists on a spectrum. It's not like there is a melanoma, there's a benign lesion and a switch gets turned on and it becomes a melanoma. Because I just talked to you about it. It's a stepwise progression to malignancy. And so there are moles that are unquestionably benign, and there are melanomas that are unquestionably malignant. But in between those, there's some probably benign, there's some probably malignant, and then there's some that are really, really, really difficult to tell. So if it's on a spectrum, then how do you figure it out? Because the reality is, just because we can't tell doesn't mean there isn't a ground truth. And what we're trying to do with diagnostics is to get to the best answer we possibly can. Is it really benign, or is it really malignant? And how do we determine that? And that's what a diagnostic is about. So when you see an atypical lesion like this, right? Now, this person makes a lot of funny nevi, right? So it's a really good question. We haven't seen their whole body. Is this really something that is pretty similar to a lot of other moles, or is this something that needs a biopsy? And so what happens? What happens if you elect to biopsy this versus elect not to biopsy it? Well, if you do, then it doesn't really change the point that either it's benign or it's malignant, right? You can elect to biopsy it and you can find out whether it's benign or malignant, or you can elect to not biopsy it and it's still either benign or malignant, whether you've biopsied it or not. So if you elect to biopsy it and it's benign, then what you've done is you've created an unnecessary scar, right? If you biopsy it, you elect to biopsy it, and it's malignant, then what you've done is you've detected the melanoma at the very earliest stage that you could have detected it. If you elect not to biopsy it and it's benign, great. No harm, no foul. It's no scar for the person, and it's a great thing. But if it's malignant and you elect not to biopsy it, then what you've done is you've delayed the diagnosis, because it's not going to go away. It's going to keep coming, and it's not going to just disappear on its own. You've just delayed the time at which you've diagnosed, and it's very probably going to give you a worse outcome than what you would have had if you had the earliest diagnosis possible. So nobody wants to do this. And in fact, even though you don't want to cause a scar, the consequences of having an unnecessary scar are much less than that of having a missed diagnosis. So what happens is that it favors the biopsy over the not biopsy. And that's where you're going to hear a lot of controversy about when do you actually do a biopsy? How many biopsies do you do? And how does that turn out? So what if you have a clinically atypical mole? This is one of those indeterminate lesions. You don't know, right? And let's say you biopsied it or you didn't biopsy it. If you didn't biopsy it, what are you going to do? You're going to monitor it, and you're going to watch it and make sure it doesn't change. And if it does, you're going to get in and you're going to have it biopsied at that time. If you biopsy it, then there's three possibilities. It can either be benign, or it can be malignant, or it can be indeterminate. If it's benign, then you're done, right? Nothing else really needs to be done. Your treatment is complete. If it's malignant, then you need to have maybe another, you'll definitely need to have a wider excision. You may need a lymph node biopsies. You may need to have some imaging done to see if it's spread to any other parts of your body. You may need some genetic testing of the tumor, and you may need some systemic either immunotherapy or targeted therapy or something else. If it's indeterminate, then you're still in that place with what do we do next? And this is what I'm going to go into later. So if you do the special stains and it's really clear, that makes it really clear and it's malignant, then you just go down that pathway. If it's really clear that it's benign, then you go down the other pathway. And that is where the special stains and FISH and CGH and the JEP test help you. Now, I just want to bring out there, and I'll talk a little bit more about this in just a second, but there's another technology that is out there now that I'm very excited about, and it's called in vivo confocal microscopy, or the other RCM stands for reflectance confocal microscopy. And this is a handheld microscope. It's basically, you put it on like a dermatoscope. I think a lot of people have seen dermatoscopes. You put it on, but it is able to send light down and receive the light back up as a microscope does. Just like when you see a microscope send light down and it comes back, it sends it down and it's able to see it at the cellular level. So what it is it's a non-invasive biopsy. So it's a way that you can biopsy the skin. You can look for whether or not the cells are benign or malignant or indeterminate without having to cut the skin. So I think it's a big progress. It's a major progress that's coming in diagnostics. So if confocal looks bad, then you're still going to have the biopsy to do all of these other things with. But if it looks really great, then you can monitor it. And that's the big advantage to confocal. So let's do a diagnosis. Let's go through it. Let's start with visual inspection. So here we go. Let's just take this mole. These are two moles that may come into a clinic, right? And they come in and this one's a little darker. It looks a little bit more suspicious. This one doesn't look so suspicious, but believe it or not, both of these are very similar when you get to the cellular level. And I'll show you that. But let's say you come in with that and you say, hey, Mr. Dermatologist or Mr. Primary Care Provider, I'm worried about this mole. Can you take a look? And they look, and if they have a dermatoscope, that gives them a huge advantage, because I think that you can see here, this looks very smooth. This looks to the naked eye, this looks like it's probably pretty benign. It looks uniform in color. It's symmetric. The borders don't look that irregular. Everything looks great. But if you look at it with a dermatoscope, and a dermatoscope is just a magnifying glass that sometimes it has polarized light, and sometimes you use oil like you see here to allow the transmission of the light to be better. And together with that bright light and the magnification, you can start to see that the edges of these this is not so uniform. And these are little, they're called pseudopods, and they're little bits of the melanocytes that are growing actively at the border and are expanding and are extending out. And it's a sign. It's a bad sign. It's a suspicious sign. It means that it's something that's happening in that mole. And so this then, if a doctor or provider ever saw something like this under their dermatoscope, they would definitely say, oh, this is clinically atypical. Now, if they have a reflectance confocal microscope in their repertoire, if they have that available to them, they can look at it. And I think you can see here, you saw those little melanocytes that I showed you. This is what they look like with in vivo confocal. You see these little yellow dots. These are melanocytes with the nuclei, and then the bright color is where the pigment is reflecting back that light. And you can see that they're big. And they have a lot of ranges, and this is abnormal. And so this shows those thickened atypical melanocytes, and this would be a case where the confocalist, that provider, that doctor, would send it for a and biopsy and would do a biopsy like what you've seen before. Remember, this is the epidermis, this is the dermis, and what you start to see, these are those melanocytes, those clusters of melanocytes, but now they're not a nice layer of them or one collection. There are a bunch of different sized collections, and the cells in there, you can't see them very well, but they don't look normal. And this would be called an atypical spitzoid cell, or maybe they would just say this is a possible melanoma. So let's continue the diagnosis. Now you've got this pathology. What do you mean, possible melanoma? Hey, doc, I thought that if you did the biopsy that you'd be able to tell me, is it a melanoma or is it not a melanoma? What do you mean it's a possible melanoma, right? And I think that's where it's really important to understand that the microscopic eye, the eye of the pathologist looking through the microscope, is not the naked eye looking at those lesions that we saw by the naked eye. And so, for example, let's just some of those things. Size and the shape of the mole is what triggers a provider to say, this is an atypical mole. It may need to be biopsied. At the microscopic level, the pathologist looking through the microscope says, the size and the shape of the cells that make up the mole are a little atypical. But just like there's variability in the size and the shape, and where is the cutoff of what's acceptable and not acceptable, the same is true at the microscopic level. The naked eye, the dermatologist might say, color and color differences of the mole make it suspicious. Well, a pathologist might say the amount of pigment and that the cells are producing is the problem. But again, that's variable and it's not black and white, right? It's a spectrum. The dermatologist might say, ooh, this is changing or growing. This mole has changed since the last time I saw it. That's a suspicious sign. Well, at the microscopic level, you can tell how many cells are in the act of dividing. Those are called mitoses, and you can tell how many are doing it. And that's another measure that they use. But again, how many mitoses does it take before it's too many? And it's a sign that it's actually become malignant. There's a gray zone there. And maybe it looks red, or there looks like there's some color that's changed, that's been eliminated. That's a sign for a dermatologist that maybe your mole is going bad. Well, the cellular part that is the corollary of that at the cellular level is if you see inflammatory cells coming in, or you see fibrosis that's changed. And so even if this doesn't all make that much sense to you, the bottom line is that the magnified eye has more information, but it is actually just as subjective as the naked eye. Having a pathologist look at it, that's why there is so much discrepancy between one pathologist to another, just like there is from one provider to another about what is in that indeterminate area. So let's keep going. Let's add some other special stains maybe that the pathologist might have in their portfolio that they could try. There's a lot of new stains, and the really cool thing about these stains is that they have been identified by looking at the cell and the proteins that are important for identifying when a cell has become malignant. So, for example, Ki67 is a stain that marks whether or not there's cellular division happening. So if you stain with Ki67, you're going to be able to see better how actively dividing is that cell, which is a sign of malignancy. Similarly, one of the most important senescence genes, a cell that keeps it from growing, is CDKN2A or P16. And that, if it's missing, that's one that can also be a clue for the pathologist that this is a malignancy. So again, I want to reiterate, every melanoma is genetically unique. They all have different problems. And so even though you've got a nice panel of stains, and these stains will allow you to mark abnormalities on the cells, not all melanomas have each one of these abnormalities, and you don't have stains for every possible abnormality. So what does that come out to mean? It means that even though it's a really good piece of information to have, it sometimes isn't able to tell you whether or not to prove that this is a melanoma. So if special stains aren't good enough, then what's the next step? And that's where we get into the first of the molecular tests that I'm going to talk about, which is called FISH for short. It stands for fluorescent in situ hybridization. Fluorescent means that the markers that we're going to look at fluoresce. So you look at them in a dark room under a microscope so you can see the light, and you look at it with a black light that stimulates them to fluoresce. And so that's kind of cool. I'll show you a picture of that in a minute. And in situ means that it's actually in the tissue itself. Like what we look at histology is in the tissue. And hybridization just means that it's binding to the tissue. So again, let's go back. We have here's your melanocyte, and here's the nucleus. And in the nucleus, you have the DNA. And the DNA is packaged into the chromosomes. And the chromosomes are where the DNA actually is. In the case of melanoma, the two chromosomes that are most important for FISH are chromosome 6 and chromosome 11. And so with FISH, what you're determining, you have these little stains, these little probes that bind to the DNA. They match up with the DNA, but they bind to DNA that is important for controlling melanocyte growth. And so if they're out of whack, then if you have too many copies of them, or you have too few copies of them, then what that tells you is that that cell is not going to be functioning completely normally, because those proteins that are made from those pieces of DNA are important for regulating the growth of the cell. So in fish, gene copy numbers are detected by the probes that are labeled with fluorescent markers, and we have one up here on that this is called the P or petite arm, and this is the Q arm. The RREB1 probe is important for that gene that we know helps control melanoma. We one here, CEP6, another one here, MIB4, and another one here, cyclin C7D or C7D. And these 4 probes can be applied all at the same time. You break open the cell so that the probes can get in. They bind to the chromosomes, and you start to see whether or not there's one copy or less than 2 copies. I'll show you an example. If you really want to look at this cool booth, there's some places you can look at more detail if you want. So this is what they actually look like. This is what the pathologist who's making the diagnosis looks like. So to orient, this is a piece of the tissue at high magnification, and all of these little blue circular things are the nuclei of the cells. They're stained with a dye called DAPI, and that makes them blue, and that tells you where the nuclei are. And then what you can see here is a normal cell. This is a normal nucleus, and as you would expect, every cell nucleus is supposed to have 2 copies of every gene, one from your mom and one from your dad. And so these are the genes that I just told you about that are important for regulating melanoma. And in a normal cell, you have 2 yellows, you have 2 reds, you have 2 blues, and you have 2 greens, and it looks perfect and there's no problem. Now, if you have an abnormal cell, this is a nucleus from an abnormal cell, and you can see that there's there's 4 blues, 1, 2, 3, and you can barely see that blue one right there. And that's another problem, right? Because there's some subjectivity here. You can't, it depends on how good the pathologist's eye is. But there's 4 copies of the blue, there's 1 copy of the yellow, 1 copy of the red, and 3 copies, 1, 2, 3 of the green, right? Now, if you look at a melanoma is even more dramatic, right? You've got multiple copies of multiple genes, and even complete loss of other genes. And again, what I want to point out here is that every melanoma is just unique. So fish identify abnormal numbers of multiple genes, 4 different genes simultaneously. But again, it's the dermatopathologist, pathologist, molecular pathologist has to look at it, make a call. How many cells like this do you need for it to be called a melanoma? How many different colors in the nucleus need to call it a melanoma? It is incredibly informative when you see something like this and all of the other stuff is still indeterminate for you to say, this is probably a melanoma. But it doesn't detect the specific mutations, and it doesn't always prove it's a melanoma. So there is still an indeterminate category. So that takes us to the next kind of test. It's called CGH, comparative genomic hybridization. And the A stands for array comparative genomic hybridization. And again, this looks like a complicated slide, but I'm gonna take you through it slowly. So if you want to watch a video, this is a really nice video, and there are other videos out there that can explain it in more detail if you're interested. But let's just start with that. We're trying to make the diagnosis. We've got an indeterminate mole. We don't know whether or not it's really a melanoma. It's a possible melanoma. So what you do is you take the tissue block, the biopsy that's been done, you take that tissue block and you take some cells out, and you take similarly some normal control cells. that are just a standard normal DNA. And what you do is you break open the cells and you pull out, extract out, and purify the DNA out of those cells. So now you've got DNA from your questionable biopsy that we don't know what it is yet, and you've got good, normal, healthy DNA. Then what you do is you take the questionable DNA, the possible melanoma, and you label it with, you just put markers in the DNA that make it red, that make it fluoresce red. And in the normal cells, you basically do exactly the same thing, but you make it fluoresce green. And then you bind it to a slide, right? Now this slide is why they call it an array comparative genomic hybridization, because believe it or not, what is on this slide is the entire human genome. So the human genome has about 3 billion DNA bases in it, 3 billion. But you can spot DNA from you can break it up into chunks of about 100,000 base pairs. And each one of these little tiny dots on this slide have about 100,000 base pairs of DNA from the human genome. And what has happened is it's in sequence. So they put the entire genome in blocks of 100,000 base pairs onto a single slide. And then what they do is they put the red DNA from the possible melanoma and the green DNA from the normal DNA. And when you look at them together, you can see it looks red here, it looks green here. But what you can tell when you overlap them is you can tell whether it's more red, like this spot, or more green, like one of these spots, or more yellow. Because when you add green and yellow light, it means they're about equal, right? So if you have a red spot, that means that you've got more of that kind of DNA in that bad melanoma, possible melanoma, in that part of the genome, in that 100,000 base pairs. You've got more of that particular gene in the melanoma, the possible melanoma, than you do in the normal. Whereas if it's green, then you've got more. That means you have less of the red. And if you have a yellow color, then it's about the right amount. That means they're about the same. So again, if you have red color, it's more copies in the melanoma. If you have a green color, it's fewer copies in the melanoma. And if it's yellow, it's about the same number in the normal and the melanoma. I shouldn't call it a possible melanoma, I should say. Now you can quantify this because all of this light can be measured. And so you can see that these are all the yellows right here along the line where they're about the same. And this is where there's too much. These would be red, and this is where there's too little. So it would be green. And here's the actual picture that the pathologist sees to make the call. So what you see here is this is a regular mole. It's called a melanocytic nevus. This is just a regular, normal appearing mole. And what you can see is that the normal control DNA was probably, what we have here is we have 2 copies of an X and no copies of a Y. So that means this came from a female patient, but all the rest of the genes in chromosome 1, 2, 3, all the way through all of the chromosomes, everything else was at about the right level with the normal control DNA, except for you had 2 copies of X and no copy of Y. Now, in a melanoma, what you see is there are several places where you have either 2 copies or 1 copy, and maybe 3 copies here of this one. And what that suggests, especially since this is in chromosome 6, remember that was an important one, and one that's really important is 9p, which is right here. It's very commonly lost in melanomas. And so you can start to see that indeed, this pattern is able to show you that this is more likely to be a melanoma than it is to be a nevus. So CGH identifies if a melanoma has too many or too few copies in any gene, not just the 4 that were in fish. Now you can look across the entire genome. It's objective because you can quantify it. It is informative, incredibly informative, but it still doesn't tell you what mutations are there or even always prove it's a melanoma, right? Because how many of these changes do you need before it's an actual melanoma. There's still an indeterminate category. So let's keep going. Let's go to the gene expression profiling, or GEP test, right? Gene expression, so to understand where it's coming from, let's just review a minute about where we've been with FISH and with CGH. So FISH was looking at the DNA in the nucleus, right? And CGH was looking at the DNA. But the gene expression profile test is actually looking at RNA. And remember that RNA is a copy of the DNA. It's not actually the place where the DNA was caused to be. It's further from the cause of the problem, but it's also closer to the function. So when you have more RNA made, you usually get more protein, and that causes the abnormal pattern of behavior of the cell through the protein. If you have more RNA, you get more protein. If you have less RNA, you get less protein. So measuring the RNA is a way to tell whether or not there's a normal or abnormal amount of these really important proteins there or not. And so what you do with the gene expression profile test is you take the biopsy of your mole, right? And then you take the tissue and you remove the RNA now, not the DNA, the RNA, and you measure how much of a panel of RNAs there are. So you can't test every RNA, and this gene expression profile test is a profile. It's not the whole entire genome. It's just selected RNA molecules that are known to be associated with melanoma. And so you measure how much of the RNA of a whole set of about 20 to 30 different genes that are known to be important. And you then compare the profile of the expression of those 20 to 30 genes. You compare it to moles and you compare it to melanomas, and then you determine a probability of malignancy based on whether it's more similar to the moles or more similar to melanomas. And so let's go through that in a little different way. So you take RNA, the way that these were developed, that these assays were developed, is that RNA was extracted from many melanomas that were clear melanomas. And they took that RNA, and then what they did is they compared it to the RNA from many, many benign moles, right? And the thing that's interesting is they did not use the indeterminate. They wanted to make sure that they knew absolutely, was it melanoma or was it not melanoma? And then they said, okay, these are the genes that we think are going to be the best markers to determine if those levels change, that it's either a melanoma or it's not a melanoma. So now you take the possible melanoma that we're talking about, that we looked at from the beginning, and you say, where does the expression of those RNAs, those 20 to 30 RNAs, which pattern does it look most like? Does it look like a melanoma, or does it look like a benign mole? And that's where you get even more information about whether or not your questionable mole is really a melanoma or really a mole. So gene expression profiling identifies if an indeterminate mole has RNA levels in 20 to 30 genes that are similar to melanomas or more similar to moles. It's objective, informative, but it doesn't prove it's melanoma, and there is still an indeterminate category where it's not a pattern that looks classic for either melanoma or moles. So I want to make some final clarifications, and then we're going to sum up. So for molecular testing, I think one of the things that's important for RNA, there's a lot there's two types of RNA gene expression profile tests that are out there, that are on the market, that people may have heard about and may have had run on their suspicious lesion. There's a diagnostic marker, which is the one I was just talking about, but there's another kind of gene expression profile that's called a prognostic marker. So with diagnosis, remember what we've been talking about is it a mole or is it a melanoma? Prognosis assumes that you've already put it into a category of melanoma. You don't use a prognostic gene expression profile test on a potential mole, because it's not gonna work. It's only telling you whether the melanoma, once you know it's a melanoma, whether the melanoma is likely to spread and kill or not. So those are two different things, right? So in the diagnosis, there's two different kinds of JEP tests out there now. There's one that uses a tissue block that cuts out part of the tissue itself. And there's another one that is testing cells that are pulled off of the mole by using tape stripping. But both of them are diagnostic. They're trying to determine whether it's a mole or whether it's a melanoma. One more set of clarifications, I think, just to sum up. Let's go back. We have FISH and CGH that show how many copies of the DNA are in the cells. Too many copies or too few copies is both abnormal, but it doesn't determine if the copies are doing anything bad for the cell. It's not associated with the function of the protein, and it's not 100%. Gene expression profiling shows that there's an abnormal amount of RNA from particular genes that are really important in causing melanoma. So it's getting closer, it's closer to the function, but it still doesn't explain why. And so there's overlap between acceptable levels. Every melanoma, again, unique, and there's still an indeterminate zone. It's just a smaller indeterminate zone. So you might say, well, what have we accomplished with all of this science, all of this technology? What in the heck? We still have an indeterminate zone. But I want to point out to you what's happened, because in ancient history with respect to melanoma, all you had was a great exam. And the great exam kept you really cannot tell the probably benign from the probably malignant by an exam. We've got dermoscopy now. We've got confocal microscopy that's narrowing that indeterminate zone even further. We've got biopsies with special stains now that are helping us to narrow the indeterminate zone. We've got FISH and CGH with DNA, and we've got gene expression profiling with RNA, and all of these are basically whittling down that indeterminate zone so that we are becoming more and more confident that we have accurately decided whether or not this was a melanoma or not. This, I just want to point out, I'm going to end where I sort of started, is that this is basically the macroscopic naked eye. This is the microscopic cellular level, and this is the molecular level. And it takes all of them when you run into a problem with indetermination to figure it out. And I'll end, this is my last slide, I promise. Together, we can eliminate melanoma as a cause of death. So join us. We hope you'll join us. These are my acknowledgments for all of the amazing people that have helped us. And I thank you very much for your attention. And I hope you have some really good questions. I'm excited to answer them.
Dr. Leach, thank you so much for what an informative conversation. We do have time for just a couple of questions.
Yes, absolutely. I think I need to turn off my phone, though. I'm sorry. Can you hear me now?
I can, yeah.
Right. I think it's going to work.
So first and foremost, thank you for kind of hanging in there with us through these technical difficulties, and what an informative conversation. I think I've watched it now 3 times, and I think each and every time I've taken something new from it. But you said so yourself, this is tough stuff. So if people are feeling a little overwhelmed by it, what do you think is the one takeaway that you really want them, if nothing else, this is what they should walk away from this talk?
Right. I think it's that there are limits to science in the diagnosis of melanoma, and that we're getting better and better and better at making a correct diagnosis, but we're not at 100% by any stretch of the imagination. And that it's because of the science that we're getting so close to being able to diagnose nearly all of them. So that it's very important to support the science, because that's the way that we get better and better.
Yeah, yeah. It's kind of it's shocking to think of the work of a dermatologist or a pathologist as being subjective, but as you presented, it really is. How do you talk about that with your patients?
I actually talked to them pretty similarly to the way that I talked about it in the video, but I think what I do is I break it down based on what their specific question is at that time. So many of the people that are watching have probably had an immunostain that was done, and so when my patient gets an immunostain back that's abnormal, I can go through that. Or they've had a FISH or a CGH test, or they've had a gene expression profile test. And so the best time, the most teachable moment, is when you've actually had one of those tests and you need to understand what that means to you. And that's usually the best time to go over how it works and what it means.
Yeah, and this might be a silly question, but Dr. Leachman, would you know if your dermatologists or pathologists have used some of these like stains or more advanced tests on one of your biopsy samples?
That's a good question. You know, I think that what underlies that question is, how does a particular provider, choose to communicate with their patient, right? And so there's about as many different communication styles as there are people out there. So I think it's a really hard question. I certainly tell my patients, if I'm going to be sending another test, most of the time, I guess, some of the time, if it doesn't reveal anything new or it doesn't give us any new information, there's probably not too much of a point in that. But like, for example, the gene expression profile test, that one, whether it tells you something, no matter what. It tells you if it's on the benign end of the spectrum or the malignant end of the spectrum. And so it's something that if you do it, you're going to report something back. But I don't know. I usually report mine back, but I guess not everyone does.
Yeah. And getting to that gene expression profiling test, do those help inform future treatment options for a patient who then, does have a melanoma detected by those tests?
Not so. It's important. I didn't have time to really talk about the difference between all of the different tests in detail, but there's a gene expression profile that is more for diagnosis, which is the topic that we were talking about today. And there's a gene expression profile that is for what they call prognosis, which isn't telling whether it's a melanoma or not. It's telling whether the melanoma is more aggressive and whether it has a higher propensity to spread and kill you or not. And so the ones that are for diagnosis, it doesn't tell you much about treatment, really. What it tells you is whether you need a further, whether it needs an excision. That's a treatment, I guess, so it can help you know that better, but it doesn't tell you what type of treatment or how aggressive the treatment might need to be. The prognostic gene expression profile is more of a guideline for how much you need to be followed up, perhaps. And perhaps if it's on top of say you have a positive sentinel lymph node biopsy, and in addition you've got this, it might sway a provider, a medical oncologist, to consider adjuvant therapy in some cases that they might not, for example. And so, it influences. I guess what it does is it informs. Those tests provide more information to inform the decisions we make. And that's the way I would look at them.
And then I think we have time for just one more question. And I think this really speaks to some of the chat about being in a rural and urban area. What if you are in a part of the country where your dermatologist isn't using some of these new technologies? What can people do?
So this is one of my favorite topics, actually. You know, I'm a real advocate for empowering the patients. I think that it's incredibly important. And we're entering an era like none before where the patient is going to have the power. We've got phone apps that are going to have all kinds of diagnostics on it. We've got all these ways of doing that. And if you think about what one of the most influential things that a patient can do, it's to ask for these things. It's to be informed themselves. The best consumer is an informed consumer of anything, not just Men's Warehouse, right? And so if a patient, and if you think about, you know, pharmaceutical companies have figured this out, right? They advertise on public television stations about the purple pill and whatever latest thing is. And the reason they do that is because it's probably the most effective way of changing physician behavior towards use of their particular drug. And the same is true of every kind of test or technology or medicine that we use in dermatology and in melanoma. It's the same. So having a person, if you want to really do something great, it's not only to advocate for yourself, but to realize that you're becoming a little mini social activist. So if you're in a rural area and you want more advanced care for your rural area, you get out there and you get everyone to ask. And it's kind of like Alice's Restaurant. I don't know how many people know about Alice's Restaurant, but you have one person ask, and it's just one person that's crazy that's asking. You have two people ask, and it becomes a movement, right? And that's the way, and it's truly powerful because nearly all doctors want to help their patients. And if they have a patient that's asking about something, that is probably the single most incentive they will have to become more up to date and to be able to offer them better care. So I think that's a really important thing.
Yeah, so that means everyone who's listening to this, either live or the recording later, you're now going to be part of that movement when you request and ask for some of these things to elevate not only your care, but the care of the entire community. Yeah, I really just want to thank you, Dr. Leachman. This has been an incredible presentation. And yeah, and I wish we had more time.
Yeah,
I'd like to thank.
Well, it's fun. It's fun to be able to be on and hear the questions and can I just say one more thing about the movement before we go?
Of course,
because we do have a War on Melanoma movement that started out in Oregon, is spread throughout the entire United States, and I think that you guys were kind enough to put it on one of your your little benches or whatever, the booths.
It's in the
electronic booths.
Check it out. Yeah.
Yeah. So anyway, if anybody that's really motivated to become a part of the movement, we've got a movement for you.
I love that. No, Dr. Leachman, this has been fantastic. Thank you again. Thank you.
Yeah,
and
thank you.
Everyone else who's joining and still with us, I'd like to thank you again for getting through this with us. We know that the technical difficulties have been really difficult maneuver through. But what I can say is that the science, the presentations, the conversation, the community that we've seen throughout today has really been inspiring. For me, sometimes it felt really dispiriting, just kind of struggling through. But then I look at the chat and the beautiful comments and the incredible, inspiring people. Like, that's why we're here. So I'd like to thank you again. I'd also like to thank the sponsors who made this possible at the presenting level, both Merck and Novartis. And I'd also like to thank our gold and silver sponsors. Before we break, I'd like to give some guidance on how the next portion will work. I'm also going to put this into the chat because I know sometimes we've been having some issues with folks understanding what I'm saying. We have two options for you to network and get to know some of the other folks who've been participating today. The first is one of 10 discussion roundtables that are available under the Sessions tab on the left-hand side of your screen. Topics range from melanoma survivorship to early detection to prevention. And on top 15 on-video participants in a first-come, first-served basis. And that's so that you can really dig deep and have a meaningful conversation. The second option is great if you're looking for more one-on-one networking opportunities, and it's similar to speed dating, if you've ever heard of that. So to access this, go to the section on the website instead of the network, and it will do you with another person for as little as 30 minutes. You can extend the 30 seconds to now. You can also via the housekeeping. We will be making sure that all of our things tomorrow. And
that's the background.
Definitely. Every thing. Thank you. We will definitely the for the next. So and we'll see you all